In the last video, I just stopped here I will give you a question like to solve this one. Negation P, disjunction Q. So here is the result, that is true, false, true, true. If you see the previous one lecture video, then you see that P implies Q has the same truth table like this one. So with this, our next part is, this is called the propositional equivalence. Sometimes it is called the logical equivalence also. Right? Now, here you have to show that this part is same as the P. So for this type of problem, we have to find out separately this one part, and you have to find out this one part, and ultimately you can see that this is equal to the P. So our result is truth. Look at this one. This is a truth table. This type of simple question is asked in the examination also. And in this way, you can solve this problem. There is the another one method. Also, here some properties we are using. So first we go to the algebraic law of the connectives. Then we solve the previous slide. What is that algebraic law of connectives? Look at that. This laws you already know in the set. Here I will take the references A union A equal to A. Here U set, that is the universal set. Here in the propositional logic part, we call it a tautology. And phi means here the contradiction. Okay. So accordingly, here idempotent law, associative law, commutative law, distributive law, De Morgan's law will be changed. Okay. P tautology, P conjunction tautology, P disjunction tautology is tautology. This type of laws which we already used in the set, also we will use in this part. Right? Now, you can solve this problem using the truth table method, or you can use the same problem using this one. Both are valid. Whatever the method is easier to you, you can solve any one of this. Okay. Next one is the very much important part, that is called the normal form, CNF and DNF. Okay. CNF is called conjunctive normal form, disjunctive normal form. Conjunctive normal forms, whatever it is, between them conjunction is needed, or between them disjunction is needed. Okay. PQ, it can be, P can be, you can write it down in this way also. P1, P2. This is can be the P1, but this sign should be in between these two. Conjunctive or disjunctive. Conjunctive means conjunction is made in the between two propositional function, and disjunctive normal form means between two propositional function there should be a disjunction. Okay. So here some problem is there. Write CNF of the following statement, this one and this one. If you break it in this way, you will get that this one is the conjunction sign. So this and this two are the separate propositional function. So this is also the CNF. Now we have to make it into the CNF format. So we will do in this way. As this is a negation, so first we have to do the negation work. Then we will use here the De Morgan's theorem. Then we will use the distributive and De Morgan's. Next we will get this type of form, because we needed this conjunction in each and every, between each and every functions. Okay. Look at that CNF, DNF. You can also use the laws. Here we will use the law. Previous part, we also use the law. You can also do it using the truth table also. Okay. Next one is the argument and valid argument. In the real life also, if you are do some arguments, so you have some, you want some basic validations, right? If you argue with anyone, then it should be valid. So here also some propositions you have given. Based on the proposition, you are concluding some another statement or proposition. That means with basis of this, you are validating this one. That's why P1 conjunction P2 conjunction P3. If this implies the Q and this function, if it is a tautology, then we call this is valid argument. If it's false or contradiction, we call it is a invalid argument. Okay. So with this part, this is the last slide of this video. That is, we are doing here a tautology. What are the propositions you have given? This is your capital P1. This is capital P2. This is P3. Now we have to show that P1 conjunction P2 conjunction P3 implies negation P. And we will see that last line we are getting a tautology. That's why it is a valid argument. The questions is like in this way. These arguments are the valid arguments of this conclusion. Okay, in this way it is asked. So the answer you have to write down in a tabular format or propositional table format. I think this part is clear to everyone. I just go through the previous slides so that you can again memorize it. So this is all about the propositional logic. Okay. Thank you, everyone.